This is the second revision video for section 2.2, Everyday Consumer Products. In the first video we looked at alcohols, and in this video we're going to look at carboxylic acids. The distinctive feature of the alcohols, if you remember, was the fact that they all contained the OH group, the hydroxyl functional group. For carboxylic acids, the distinctive feature of the functional group is the carboxyl. The carboxyl is a carbon atom which has got a double bond to an oxygen and a bond to an OH group. That's it drawn out in its full structural formula manner. It's also acceptable to draw it like that, not showing the bond between the O and the H, or in the more shortened version it would be drawn like that. So they all represent the carboxyl functional group, and that's what you find in all carboxylic acids. So here's the first three carboxylic acids. So the 1 carbon methanoic acid, 2 carbons ethanoic acid, 3 carbons propanoic acid. Now the one good thing about naming carboxylic acids is that the carboxyl group is always on the end carbon, so it's always on carbon number 1. Okay? It can't be in the middle, it's got to be at the end. So there's only one type of propanoic acid. If I say butanoic acid, there's only one structure you can draw, so there's no sort of numbers that have to be put in, because the carboxyl group is always on the first carbon atom. So let's look at the properties and therefore the uses of carboxylic acids. Well, first of all, solubility. So it's a bit like alcohols. So small carboxylic acids are soluble in water. So you remember that all the hydrocarbons, the alkanes, alkenes, cycloalkanes, were not soluble, were not miscible in water, whereas the alcohols, the small ones, were miscible in water. The alcohols had that OH group, which is kind of similar to the water, which has 2 OH groups. Now the carboxylic acids also have an OH group, so their solubility is more like the alcohols than the hydrocarbons. So the small ones are soluble or miscible in water, but as the size of the molecule increases and you get more carbons and hydrogens added on, the solubility decreases. The melting boiling points, the trend is the same as for all the homologous series we've looked at so far. As the molecule gets bigger, the attraction between the molecules increases, and so the melting boiling points increase. Now, by far and away the most important property of the carboxylic acids, and one surprisingly that people often forget, is that they're acids. Okay. So solutions of carboxylic acids are going to have a pH less than 7. So here we have a solution of ethanoic acid, and we'll test its pH by adding some universal indicator. So let's add a few drops of universal indicator. Give it a wee mix up. So we see we've got a very acidic solution with a very low pH. So don't forget that carboxylic acids are acids. That's a very easy way to quickly identify carboxylic acids, is to test the pH. So since they're acids, they're going to react to bases like any other acid, like hydrochloric, nitric, sulfuric acid. So it will react with metal hydroxides to form a salt and water, metal oxides to form a salt and water, metal carbonates produce a salt and water, and carbon dioxide, of course. So for example, if ethanoic acid reacts with the base sodium hydroxide, we get a salt and water. The salt would be sodium ethanoate. If it was methanoic acid, it would be sodium methanoate. Propanoic acid, sodium propanoate. Okay, what about the uses of carboxylic acids? Right, they're actually a good starting point for making a lot of useful products like soaps and medicines. And one carboxylic acid which has a lot of uses in our society is vinegar, which is a dilute solution of ethanoic acid. Now, obviously we put it on food as a flavouring, especially chips, but more widely it's used as a preservative. So in pickles and chutneys, the food is preserved by the vinegar. The low pH stops bacterial growth and so stops the food going off. So it's a really useful preservative for keeping food fresh. It's also used as a household cleaner, particularly for, this is showing a kettle with a line scale on the heating element. Now, certainly in Arran we don't get much line scale, but in other areas of the country you get a lot of line scale building up. And line scale is just a base, and so it will react with vinegar. Now, the lime scale would react with other acids as well, but the attraction of vinegar is that it's a non-toxic chemical, and so it can be used in the house and in the kitchen without any health problems. So, 3 things you must be able to do. You should be able to recognise and name members of the carboxylic acids with up to 8 carbon atoms. You should be able to recognise a carboxyl group, whether it's drawn as the full or shortened formula. And you should be able to recall the properties and uses of carboxylic acids.